Hey, hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to this video demo of humidity monitoring system for hospital storage using Cortex microcontroller, humidity sensor, and TDCA. So this system is designed to monitor humidity levels in hospital storage areas in real time, ensuring that medical supplies are kept under safe environmental conditions. In this video, we will explore the system's working principles, core components, and how TDCA facilitates the real-time monitoring and remote adjustments. So let's see what is TDCA first. TDCA, Target Device Communication Interface. So here the host applications sending the command to the target monitor via the serial communication, and the command is getting processed from the target hardware side and then return back the response to the host system via the serial communication. So this is the mechanism used in this TDCA. Now let's see the overview of the project. Here, the Cortex microcontroller processes the humidity data from the sensor and checks it against the safe humidity thresholds. And then the humidity sensor measures the environmental humidity levels and provide the analog output. So the TDCA enables this real-time data transmission between the host and target hardware. So the primary goal is to ensure that hospital storage environments remains within the safe humidity ranges and protecting the sensitive medical supplies. So let's see the components. Humidity sensor HR202. So this is the sensor we are using here for checking the humidity level. So this sensor measures the relative humidity by detecting changes in resistance due to the moisture in the air. So the microcontroller converts this analog signal to a humidity value using a ADC. In the Cortex microcontroller, this is the brain of the system processing the humidity data and controlling the alert mechanisms. So this is the target board we are using here, and then LED for indication purpose. In case if the humidity level will go high, then we can give a LED indication to the people. And then the TDCA that ensures a seamless communication between the microcontroller and host system, allowing real-time monitoring and remote configuration. So let's see how this TDCA integrate with the system. The host system actually sets the predefined humidity threshold value and receives a real-time sensor data from the Cortex board. This Cortex continuously reads the humidity level from HR202 humidity sensor and check them against the safe range. If humidity exceeds the set limit, then the microcontroller triggers the alert system and transmits the current data via TDCA to the host. This feedback loop allows hospital staff to monitor and adjust the humidity range dynamically without modifying the microcontroller code. So this project widely used in pharmaceutical storage, which protects drugs and vaccines from the degradation caused by the excess moisture, and also used in sterile supply rooms to maintain the humidity within safe levels, to preserve surgical instruments and equipment. And also we can use this project in medical device storage to prevent the moisture related damage to sensitive electronic devices, and also especially used in blood banks to make sure proper environmental conditions for the preservation of blood and plasma. So these are the wide range of areas we can implement this project. So now let's see the coding. So coming to this coding part, you should include TDCA.h header to use TDCA API calls, And then from OS application start function call. So this is like a main function. Inside this, you should initialize TDCI init in the beginning of your code. So this is the important API to make a serial connection between the host and target. So don't forget to use this. And then the following STM API call. So here I'm using the ADC HAL API. Now let's see the console output. I'll right click open with system editor. So my code is started running and you can see that each API is executing one by one and you can see the success status of each API. So you can see that humidity value. So it is ranges 8.95 and you can see the humidity value is coming 8 9 like that. So you can see that. So for this I'm just using the LED indication if humidity ranges become high. So if it is exceed the preset threshold value, then LED should be on for indicating the people that the higher humidity level is going on like that. If it is normal humidity value, then LED should be in off state. Let's see the hardware setup now. So coming to the hardware setup, so this is my humidity sensor, and for indication I'm using a LED and then Cortex board. So I gave required connection between the sensors and the board. Now I'm going to run this. Before that, please make sure you reset the board, and I'm going to start the project. Okay, now it started running the project. So you can already see the console output before. So it just executing the API one by one, and then it started reading this humidity sensor value. So it continuously detects the humidity level of our surrounding and then giving you the value. So in case if it is high, then the LED will started glowing. If the humidity level should be high, actually I'm setting a threshold value for this humidity level. So if that level got increases, then LED should be on. So if the level going to be below that set threshold value, then it is giving you the normal range of humidity value. When the humidity goes to a normal range, then it goes on off state. So this is how we can monitor the humidity level and gives a LED indication to the people to alert them the humidity level goes high or it is a normal. So that in conclusion, this humidity monitoring system demonstrate how the Cortex and TDCI can work together to ensure optimal storage condition in hospitals. So by providing a real-time data and immediate alerts or indication, the system plays a crucial role in safeguarding the sensitive medical supplies and equipments. So thank you for watching. If you found this video helpful, please follow us and leave your questions or comments below. Stay tuned for more innovative embedded projects. Bye.